I'm Anil Kumar, and now it is time to see the limits and equations and their graph in the reverse order. So in this particular video, we'll start from the limit, sketch a graph, and then write down the function itself or equation of the function. Let us take examples in this video where limit exists. Okay, so we'll take examples where limit exists, right? As x approaches a, right? So those are the examples which I am taking in this video. In the next video, we will consider one-side limits. Okay, so let us say that we have a function f of x. Let me write down it differently. So we have a function f of x whose limit exists as x approaches 1, and let us say the limit is 2, right? Now in such questions there could be two possibilities. One possibility could be that the value of the function is same as the limit of the function, right? So that could be one possibility. And if that is the case, in that case you will have a continuous graph, right? So we are considering two different possibilities here. One possibility, as I said, is you're given this, and you're also given that the function is continuous, okay, or right? So in that case, it is kind of very simple. When you say limit of the function is equals to 2 as x approaches 1, in that case, what you can do here is that at x equals to 1, let's say this is your x-axis, this is your y-axis. You know, x approaches 1, the value which you are getting is 2. So basically, normally when it is a limit, you have to mark it as a whole. Now, if I say here that f of 1 is equals to 2, in that case what really happens is that this value makes the function continuous at this point. So this hole gets filled up. So that is the concept. So you get a continuous function at x equals to 1. Now the best function to draw here is a straight line. So I'll always prefer you to sketch a straight line, which you could do a horizontal or you could go through origin. So going through origin is a good option. So we have a straight line going through this point. So that is the graph of the function, right? So once you draw the graph of the function, we can now write down the equation. So we say f of x is equal to, since it is continuous, right, and the value is same, so it is just one polynomial function most of the cases, right? So a line going through origin and this point, which is 1 and 2, so that means slope is 2, right? So it could be 2x. So that could be one possible function. Now let us consider the same example, but in this case what we will do is we will say that the value of the function is different, right? So I'm just changing the question a bit so that we understand the concept. We say limit x approaches 1 for f of x is equals to 2. However, the value of the function at 1 is, let us say, 0. Now in that case what happens? So we'll follow the same procedure, right? So we'll follow exactly the same procedure and say, because the limit is 2 at 1, so we say this is 1, 2, 1, 2, our axis. So as you approach 1, you're approaching a value 2. So I'll make a hole here. That's the first part. The second part is the value of the function at 1 is actually 0. So we'll have a solid filled in circle there. Do you get the point? And again, we will sketch our function. And I prefer to draw a line, and that's how I normally do. So if you don't do many variations, it's easy to understand the concept and quickly get the solution. So here what we have here is, now let's write down the function. So we say when x is not equal to 1, we know when it is equal to 0 when x is equal to 1. So one part we have got, that is this part, correct? And the other part is when it is not equal to 1, then what is the value? We know the point is 1 and 2. The slope of this line is rise over run, that is 2 over 1. So we can write this as 2x. Y-intercept is origin when x is not equal to 1, correct? So this piecewise function shows that when x is not equal to 1, then the value of the function is represented by a straight line 2x. But when it is 1, the value is 0. And as you can check, if you are approaching from the left side, so limit of the function is 2. When you are approaching from the right side, limit is again 2. And therefore, the limit of the function as you approach 1 is 2, correct? So we can see here that the limit as x approaches 1 from negative side for f of x is 2. Limit when x approaches 1 from positive side for the function f of x is also 2, and therefore this condition is satisfied, and the value of the function is 1, correct? So that is a good way of doing it. At times you can also use horizontal lines, right? So we'll take up similar examples in the next video. So in the next video we'll also talk about one-side limits, which I introduced you now, and we'll give you the limits and try to see how to sketch a graph and write equation. I hope that helps. Thank you.